All right, so guys, hey, go ahead, get out your class notebook and write this down. Today we're going to figure out what is the kinetic theory and how does it relate to pressure, volume, and temperature. All right, actually we're going to focus more on just the kinetic theory, okay, and we'll talk about the other part in class. So this is what it is, guys. Pretty straightforward. A theory that the particles in a gas, they move freely and rapidly along straight lines, but they run into each other, okay? Because of that, there's variations in their velocity and their direction. Cool? So we know that gas is in the atmosphere, right? We can tell even in the air, right? If you guys have ever stuck your hand out of a moving vehicle, right? The wind that is hitting your hands is gas particles. And you can push up on the gas particles, push down on the gas particles. And inside every single balloon, there's particles, right? Inside the room, there are particles of gas, okay? So we assume that they behave these different ways, all right? So the first way that we think they assume is, or the first thing that we assume is that gases are made out of tiny atoms, right? We can't really see them, but we know that they're there, right? We can feel them if we go side to side, right? And those particles have a large distance between them. If they didn't, they would be a solid, right? Between those particles, there is no magnetic or repulsive forces. So they just travel. Nothing's active upon them, right? They're not being drawn towards each other. They're not being repelled by each other. They are just kind of being, they're just kind of moving, okay? Two more. The third thing is gas particles, they move rapidly, very fast, and they're always moving, right? They never just kind of stop, okay? And the way that they travel is random, right? There's no all 100 million don't go one way at a time, all, or then they suddenly shift. They all are just kind of randomly going wherever they want, okay? And the last one is, you guys probably remember this from physics. All the collisions are elastic, right? Meaning that when they run into each other, they bounce off in the exact same direction and in the exact same speed, okay? So let's go ahead and write these in a, so for us visual learners, we can kind of see them, okay? So our first assumption was that gas is made out of little particles, right? So we can say gas are these little atoms that are spread out, right? Cool, really easy. Second assumption is there's no magnetic or repulsive forces, right? So what that means is these atoms, they are not drawn to each other, and atoms are not repelled by each other. Okay, they are completely random, moving randomly. Okay. Third thing is they move rapidly and they travel in straight lines unless they're acted upon, right? So what that means is, let's say you have a room, right? Put some particles of gas in there. They're going to move randomly, meaning they're going to go in whatever way they want. Okay? And they're going to go straight unless they're acted upon. So like this guy, he's going to run into a wall. So he's acted upon by the wall. He's going to ricochet off of that. Okay? This guy is going to travel straight until he hits here, and then he's going to ricochet off of that. Okay? So they travel straight unless they're acted upon. And finally, the collisions between them are elastic. All right? So if two things collide with each other, if two particles collide with each other, they are going to bounce back in the opposite direction and at the opposite speed. Okay? So if you guys think of a car crash, elastic car crash would be two cars running into each other. They ricochet off of each other with nothing being wrong with them, and they are going at the same speed that they were going in. So that's a completely elastic reaction. Okay? All right. Cool. Guys, we're going to use this in the lab tomorrow. Good job watching today.